Right, dear students, welcome back to this video series where we will be looking at our A Math worksheets. Okay, so like previously, what I will do is to go through selected questions, okay, and give you sufficient hints such that you can actually move on and try the questions independently. Okay, so the hints I will be giving are for question 1, 3, and question 5. Okay, so let's look at the first question, question 1. So what happens is that in this question they are simply giving us this very complicated looking equation, okay, and without the use of the calculator we are supposed to find the values of m and n. Okay, so how are we supposed to do that? Okay, if you to notice on the right hand side, it's just a very simplified and nice equation, right? So if you multiply in 3, you simply get a constant plus some term in front of square root 2. Okay, so that is actually a nice surd. Whereas on the left hand side, you realize that it's a very complicated looking surd, and I don't like that at all. So our job is to simply apply some of the rules and laws of the surds to simplify the left hand side and make it as simple as the right hand side. Thereafter that, we will compare coefficients. Okay, so how can we do that? Let's look at it. So what I did here is simply to write down the equation, copy down the question, and I have expanded the right hand side. Okay, so 3 times minus 2 minus 6 plus 9 root 2. Okay, so one of the important skills that you need, okay, is to be able to simplify surds like that. So recall that in order to simplify surds like that, okay, we always split a number up into, right, the highest possible perfect square and a prime number. Okay, so in this case, for example, if I have square root 32, this can be written as, right, 16 times 2, where 16 is the largest possible perfect square, whereas 2 is a prime number. So that's what we are always aiming to do. Okay, so let's now look at how we can simplify 162. So with some trial and error, you should realize that, okay, 162 can be expressed as such a form. Okay, and next we look at the second and the third term. We realize that the denominator contains surds, and that is not what we want. We would hence rationalize these two terms over here by multiplying the conjugate surd. So in this case, let's see what we have. Okay, so 162 can be expressed as 81 times 2, right? 81 is the largest possible perfect square. So for the next term, I'll multiply the numerator and denominator by square root 50, right? And of course, for the third term, I'll multiply the numerator and denominator by 3 root 2 plus 4. Okay, so you realize that if I multiply both the numerator and denominator by 3 root 2 plus 4, this is basically a product of A plus B and A minus B, right? So that's simply the difference of two squares. So I would be able to use my difference of two squares formula. Okay, so simplifying this, you should have 9 root 2 plus 3 over 5 square root 50 plus, okay, so this guy over here, right, this guy over here is what? This is 18 minus 16, so this is over 2. So this would be m over 2, 3 root 2 plus 4 plus n over 2 equals to minus 6 plus 9 root 2. Okay, so what I can do is simply multiply throughout by 2 if you wish, throughout, so that you can get rid of the 2. This would be 18 root 2 plus 6 over 5 square root 50. Okay, and we realize that 50 can be expressed as square root 25 times 2. Okay, so this one would be m 3 root 2 plus 4 plus n, and you have minus 12 plus 18 root 2. Okay, so this will turn out to be 5 root 2. The 5 and the 5 cancels out. Okay, this would be 18 root 2 plus 6 root 2 plus, right, 3m root 2 plus 4m plus n equals to minus 12 plus 18 root 2. So in this case, what we are going to do is we are simply going to collect all of the root 2 terms, okay, and we are going to collect all of the constant terms, okay. So we have 4m plus n plus, okay, so you realize that root 2 is the common factor. We can simply factorize. This would be 18 plus 6 plus 3m root 2, okay, and it's equals to the right hand side. Okay, lastly what we do is we will simply conclude that the constant term is equals to minus 12 and the coefficient of root 2 will be equals to 18. Okay, so that I will leave it for you to try on your own. So I'll say comparing, and you leave it, and I leave it to you. Okay, so next let's look at question 3. So question 3 requires us to solve an equation. The equation looks quite complicated. Okay, so recall when we were solving equations linear equations back when we were in Sec 1. If you see something like 2x minus 1 equals to x plus 5, what would you do? Okay, I'm sure that your teachers will have already taught you very well that you're supposed to bring and group all the x terms to one side. In this case, I'll bring everything to the left hand side, and all the constants I will just lump them up together on the right hand side. Okay, so this would simply be x equals to 5 plus 1. Okay, let me be more precise. 2x minus 1 equals to 5 plus 1, then of course x would be 6. So when that happens, you realize that we are solving the equation. So likewise, if we would like to solve the equation, what we'll do is we will need to group all the x terms together. So in this case, we will need to expand out. Sorry, this would be 5 root 2. Okay, then after that, what you do is you will simply collect the terms together, right? You collect the terms, all the x terms together, all the constant terms, you bring it to the right, okay? And of course, you will factorize x, leaving yourself with root 3 minus root 2. That will be 5 root 2 plus 2 root 3. Okay, so what you do is simply divide both sides by root 3 minus 2. Right, then after that you rationalize. You should be able to get what you want. Okay, leaving your answers in this form. Okay, that I'll leave you to try on your own. Okay. Lastly, for question 5, right, we are supposed to show that this left hand side equals to the right hand side. So the only way we can do that is when we rationalize this denominator. Okay, so that being said, you realize that the conjugate surd is root p plus 1 minus root p. Okay, so I will simply need you to rationalize the left hand side and you should be able to get the right hand side quite easily. Okay, so I'm just going to go through the hence part. So now they are saying that they want us to find the value of this expression over here. How can we do that? Simple. I'm going to make use of part A because of the word hence. Notice that the equation given is in this form, so we can always express it as the form on the right hand side. So this would simply be square root 16 minus square root 15 for the first term. Right, this would be square root 15 minus square root 14 for the second term, square root 14 minus square root 13 for the third term, right, plus dot dot dot, and of course I have root 3 minus root 2, finally root 2 minus root 1. Okay, so when we have that, what do you notice? Okay, you should notice that this is a negative 15 and this is a positive 15. Likewise, okay, do you realize this is a negative 13, and if you write down the first term of the expression here would be positive 13. So you realize that, okay, the terms all cancel out. The terms here cancel out. Okay, and you can expect that the terms to cancel out. So finally, looking at the last two terms, okay, minus root 2 and root 2 will cancel out. Okay, so you need to understand what are the residual terms, right? So the residual terms simply are the first and the last term. So if you realize that that is the case, we simply would have root 16 minus root 1. Okay, root 16 is 4, root 1 is 1, and of course the final answer would simply be equals to 3.